Hi guys, and welcome to Faceless Guy. I will react today to a video from Kurzgesagt. It will be my first reaction to the channel, I think. So I hope it's okay. Maybe I will try to upload it also on my second channel first, just to see if there are some copyright claims. So if you see this, then enjoy it, and please like and subscribe. Also, please subscribe to him. He makes great video. Or the team, or I'm not sure. I think it's the team, but yeah. They make great videos. I like them very much often, and they explain complicated topics very good. I have also a theory now about black holes. I watched a lot of videos about black holes recently, and at the beginning of the universe, the Big Bang, maybe this entity, this singularity, this whatever it is, what was there before the Big Bang, because we don't know anything from before, or if there was a before, but this thing, maybe this thing was a gigantic black hole, and at the end of this universe, when the whole universe is, there are only black holes left, which slowly eat themselves. Maybe there will be again a Big Bang, or a gigantic one black hole, and then maybe there's a upper limit for black holes, which is the the entire content of the universe. And but I have not studied physics. I just watched some videos, so don't take anything I say too seriously. I'm just making my own series. If you have knowledge about this kind of stuff, please educate me or help me. It's just interesting ideas. Because a black hole is a singularity which is so dense, so compact, so where everything, the mass of entire suns, is so close together that I'm not even sure how exactly this works. That light, which is according to my understanding, has both characteristics of a wave and of a particle. Can be distracted from its course, from how it is moving through a big mess. So I don't understand why everything is drawn into a black hole, just because the mess it is made of is so dense together. But I'm not a physics, so let's watch this video. I just wanted to say a few things beforehand.
Things in existence.
Moment, from the beginning.
Black holes are one of the strangest things in existence. They don't seem to make any sense at all. Where do they come from? And what happens if you fall into one?
I know about the Schwarzschild radius, that you have to put you can make everything which has a mass into a black hole. When I was in school, I also calculated a bit and tried to create there's an equation from Einstein, I think, and you I'm not sure exactly if I can find this equation and put it here as a picture on the screen. But if you normally the speed v is always below light speed, which is understandable. And if it is light speed, exactly light speed v, then the whole equation doesn't make any sense, because I think it makes mathematically no sense, the equation. If there is if v is equal to light speed, but if v is above light speed, the equation that makes sense, but then the mass becomes, I think, negative or complex. But the equation makes sense again, just as the equation. And I think it was 1960 something, and through this equation, some people thought that maybe there are particles, tachyon or so, I'm not sure, which move always faster than light speed. But they're just they're not proven it, I think. But it's interesting.
Stars are incredibly massive collections of mostly hydrogen atoms that collapse from enormous gas clouds under their own gravity. In their core, nuclear fusion crushes hydrogen atoms into helium, releasing a tremendous amount of energy. This energy, in the form of radiation, pushes against gravity, maintaining a delicate balance between the two forces. As long as there is fusion in the core, a star remains stable enough. But for stars with way more mass than our own Sun, the heat and pressure at the core allow them to fuse heavier elements until they reach iron. Unlike all the elements that went before, the fusion process that creates iron doesn't generate any energy. Iron builds up at the center of the star until it reaches a critical amount, and the balance between radiation and gravity is suddenly broken. The core collapses. Within a fraction of a second, the star implodes, moving at about a quarter of the speed of light, feeding even more mass into the core. It's at this very moment that all the heavier elements in the universe are created as the star dies in a supernova explosion. This produces either a neutron star, or if the star is massive enough, the entire mass of the core collapses into a black hole. If you looked at a black hole, what you'd really be seeing is the event horizon. Anything that crosses the event horizon needs to be traveling faster than the speed of light to escape. In other words, it's impossible.
It's I think how science thinks in the moment that there's nothing faster than the speed of light, because this particles I spoke about are not yet proven. Maybe if they're even proven that they don't exist by now. My knowledge is also a few years old, but it is fascinating.
So we just see a black sphere reflecting nothing. But if the event horizon is the black part, what is the whole part of the black hole? The singularity. We're not sure what it is exactly. A singularity may be infinitely dense, meaning all its mass is concentrated into a single point in space with no surface or volume. Or
You hear me? Okay. I'm very not sure. I love physics, you know. And that's why I pause maybe more often here. But it is we know how black holes are created. So the star collapses in itself, and then all the mass becomes so dense. In the Schwarzschild radius, maybe he will mention this, I think. And I think for the Earth it would be a US penny size thing, something like this. All the matter of the Earth into a so close together that it's just a penny size thing, and then it would be a black hole. But yeah, I think we are just not sure about this thing. It's this black hole, and then becomes really is. But it's fascinating. I like it very much. It's both a little bit scary, but also interesting to see to think about this.
or something completely different. Right now, we just don't know. It's like a dividing by zero error. By the way, black holes do not suck things up like a vacuum cleaner. If we were to swap the Sun for an equally massive black hole, nothing much would change for Earth, except that we would freeze to death, of course. What would happen to you if you fell into a black hole? The experience of time is different around black holes. From the outside, you seem to slow down as you approach the event horizon, so time passes slower for you. At some point, you would appear to freeze in time, slowly turn red, and disappear. While from your perspective, you can watch the rest of the universe in fast forward, kind of like seeing into the future. Right now, we don't know what happens next, but we think it could be one of two things. One, you die a quick. What happens next?
That's fascinating. Quick death or very quick death. Awesome.
Next, but we think it could be one of two things. One, you die a quick death. A black hole curves space so much that once you cross the event horizon, there is only one possible direction. You can take this literally. Inside the event horizon, you can only go in one direction. It's like being in a really tight alley that closes behind you after each step. The mass of a black hole is so concentrated, at some point even tiny distances of a few centimeters would mean that gravity acts with millions of times more force on different parts of your body. Your cells get torn apart as your body stretches more and more until you're a hot stream of plasma, one atom wide. 2. You die a very quick death. Very soon after you cross the event horizon, you would hit a firewall and be terminated in an instant. Neither of these options are particularly pleasant. How soon you would die depends on the mass of the black hole. A smaller black hole would kill you before you even entered its event horizon, while you probably could travel inside a supermassive black hole for quite a while. As a rule of thumb, the further away from the singularity you are, the longer you live. Black holes come in different sizes. There are stellar mass black holes with a few times the mass of the Sun and the diameter of an asteroid. And then there are these supermassive black holes which are found at the heart of every galaxy and have been feeding for billions of years. Currently, the largest supermassive black hole known is S50014+81, 40 billion times the mass of our Sun. It is 236.7 billion kilometers in diameter, which is 47 times the distance from the Sun to Pluto. As powerful as black holes are, they will eventually evaporate through a process called Hawking radiation. To understand how this works,
This is also fascinating because this is a thing we don't even understand everything of, slowly disappears. And maybe if this would be something right, I think we cannot really prove this because what do we really know about the Big Bang and what or if something was before? But I mean, something from somewhere completely different triggered this maybe black hole to explode, and that's how the universe was created. But yeah, it sounds weird, but it's also an interesting idea because it's a little bit similar with the singularity and the other singularity, but of course not every singularity must be the same. But yeah, I read about Hawking radiation that slowly over time black holes disappear.
we have to look at empty space. Empty space is not really empty, but filled with virtual particles popping into existence and annihilating each other again. When this happens right on the edge of a black hole, one of the virtual particles will be drawn into the black hole and the other will escape and become a real particle. So the black hole is losing energy. This happens incredibly slowly at first and gets faster as the black hole becomes smaller. When it arrives at the mass of a large asteroid, it's radiating at room temperature. When it has the mass of a mountain, it radiates with about the heat of our sun, and in the last second of its life, the black hole radiates away with the energy of billions of nuclear bombs in a huge explosion. But this process is incredibly slow. The biggest black holes we know might take up to a googol years to evaporate. This is so long that when the last black hole radiates away, nobody will be around to witness it. The universe will have become uninhabitable long before then. This is not the end of our story. There are loads more interesting ideas about black holes. We'll explore them in part 2. A big thanks to Fraser Kane for help with this video. By the way, we've made some Kurzgesagt wallpapers in 4K for different screen sizes. You can get them on our Patreon page, which also helps us to make more videos. Like this December, the first month ever with 3 videos.
Yeah, it is awesome. I like it very much. This channel is great. And it explains things, I think, very well. At least as far as I understand. And I have seen also physics reacting to this and also explaining stuff. And I'm not physics. I'm just a fan of physics, and it's fantastic. Black holes are very interesting. Scary but interesting, and this whole universe thing. That there's a video from Real Life Lore about how the universe is so much bigger than you think. And I will also I made a reaction to this a while ago, but I will make another reaction to it at some point, I think. And it's awesome. I just don't know what else to say. It's fantastic. Please subscribe, like the video, and if you're interested, then suggest me some other videos from Kurzgesagt or other channels, and I might react to them. And tell me if you know about the stuff, physics stuff, how plausible my ideas are. Or, I mean, I'm just speculating. I'm just interested in this stuff. I would really like to know what is beyond the observable universe. I heard from scientist Alan Guth, who proposed that the universe is even much larger than the observable universe, than what we can see so far. I'm interested in the string theory and in as I heard in, I think, even one of the other Kurzgesagt videos, that there may be wormholes which were created or started to exist in the very, very, very early days or years of the universe, and which through the expanding universe, this if they really exist, this wormholes or this. I think it has something to do with the string theory, so that this holes, this strings could be used theoretically, maybe, to travel to distant places, even when the universe is so large that we cannot even see a single star in the sky in trillions of years. I'm not sure, but I heard that at some point the stars will be all gone and all the universes will be or galaxies will be unreachable for us, unless, of course, this thing works, or we find something which travels faster than light. I don't know. Physics is so crazy. I can imagine everything, even stuff which moves faster than light. Or that the whole universe starts to rotate. I just watched a short in which if the universe would rotate and not expanding, time travel would be common and possible. And physics is mindfucking, but awesome. Also a reason, I think, why I don't believe in any religion, because I can't imagine something like a god or anything like this which is greater or bigger or has more power than this universe, than just the thing we see outside or when we look up into the sky. And yes, I hope you enjoyed it, and please like and subscribe.